Number 8, double angle equations. There's 4 of them. And these are in degrees. You can spot that straight away because it's got the degree sign. But I think for the bulk of my working, I'm not going to be putting the degree signs in. Notice x is in degrees, so x just represents a number then, the number of degrees. I wouldn't be putting x is greater than or equal to 0 degrees or 360 degrees because it already has the degree sign. But I'm going to ignore the degree sign as I write it out. Well, the first step is going to be, I can't work with these 2 different measures of angle, so I need to change this back to match this, to match x. So I'm going to have to use the appropriate formula. There's 3 to choose from, but I want the one that matches cos. So I'll go for the one that goes 2 cos squared x minus 1 minus the 3 cos x plus 2 equals 0. Which means altogether I've got 2 cos squared x minus 3 cos x plus 1 equals 0. And that's a quadratic in cos. So I'll just factorise it like a quadratic. So 2 cos squared could only be, if it factorises to integers, 2 cos x times cos x. 1 can only be 1 times 1. And then to get a negative, the negative goes to the larger, but they're both the same, so that's also negative. And then the solutions would be, if that bracket comes to 0, then cos of x would have to be the opposite, that's 1 divided by 2. Cos of x is a half, and that's one of the ones that you know, so I can state the angle straight away. Or, if this bracket is equal to 0, then cos of x would have to equal 1, which equally I know just from the graph. So I could just state the answers and that would be done with, but if you wanted an illustration of the side of how it's working, it would be this. I remember that half because there's the 1, 2, root 3 triangle. It's in degrees, so that would be the 30 for the smallest and the 60 for the other one. And if the cos of x is a half, that means the adjacent one's a half, so it's 60, and it's a positive. And if I was thinking of the other ones, I could either think of the graph or the cast diagram, all sine, tan, cos. If the cos is positive, I'm either here or here. So I've either gone 60 to there, or all the way around to leave 60, which means x is either equal to 60, oops, because it's only a thing, or 300, being 60 short of it. Or, in this case, x would be, we'll just think of the graph. Whenever you've got the 1s and the negative ones and the zeros, you think of the cosine graph. When is the cos at 1? It's at 1 here at 0, and it's at 1 here at 360. So that either equals 0 or 360. So strictly speaking, the answer is going to be just 0, 60, 300, or 360 without the degree signs, because x was just the numerical part and the degree sign was separate from it. But you tend to write degree, degree, degree. But strictly speaking, those are the values of x. In part B, sine 2x, it's a double angle formula. I can only have the one type of angle, so I'm going to change that to x's. But at least in this case, there's only one expansion. It's 2 sine x cos x minus the 2 cos x equals 0. Again, I'm not putting the degree signs through everything, just being a bit lazy there. And what comes out of that? Common factor of 2, common factor of cos. So 2 cos x comes out, leaving me with a sine x, and all of that's gone, so it's just 1. And from that, if these two factors come to 0, then either of them could have equaled 0. If it's that one, then cos of x will be 0. If it's this one, then sine of x will have to be the opposite of that. Sine of x will be 1. And they just read directly from their graphs. Again, you don't need anything, you just imagine them and put the answers down. You know what the cosine looks like, you know what the sine looks like. I'll just put it down anyway at the side here. The cosine graph looks like this. So it's 0 at those 2 points. That was 360. That's 90, because it's the 4 quarters, and that's 270. So in this case, x is 90 or 270. Or, in the case of sine, sine goes like this. When does it go up to 1? Only once at 90. That means I've got the 90 mentioned twice. So when it comes to the final solution, there's only going to be 2 numbers. X is 90 or x is 270 as far as the numerical part of the angle is concerned, because the degree sign was in there already. So x is 90 or 270. Next one, part C. Double angle equation again, only it's a cosine, so I've got 3 variants of it. cos squared minus sine squared. I can see I've got a sine here, so I'd rather have all sine squareds and then have a quadratic. So I'll rewrite that as 1 minus, 2 sine squared x equals 4 sine x minus 5. Again, just been lazy and missing out the degree signs all over the place. So it'd be easier to take that this way and read it backwards. So that would then read 2 sine squared x plus 4 sine x, and that would be minus 6 equals 0. Well, I could simplify that all by taking out the factor of 2, so it'd just be sine squared x plus 2 sine x minus 3 equals 0. A nice little quadratic to factorise. Can only be sine x if it factorises to integers in the first place. You could get a nasty one where you'd have to use the formula. If you were using the formula, I'd have to say instead of x equals negative b, it'd be sine x equals negative b plus or minus, etc. Then once I had my two answers, I'd have to do inverse sine of them both. But this one looks as if it's going to behave itself. That's 1 times 3. The plus goes to the larger, and that says they're opposites. So the answer would be either sine x equals 1, if that bracket is 0, or, even better in this one, sine x equals negative 3, if that bracket is to be equal to 0. Well, that's quite handy, because sine can't get higher than 1 or lower than negative 1. So you're never going to get down to negative 3. So for this part, there's no solution. So that's that part dead. And for the first part, well, it only goes up to 1 once, and that's at 90. Which means that's your only answer. X is 90 is the only solution to that equation between 0 and 360. And for D, this one, well, it's the same as the last one because I've got sine and I've got a cos, which I'm going to change into sine squared. So I'll change into 1 minus 2 sine squared x will be 1 minus 2 sine x degrees. Then it's just a case of, I think I'll take it over this way and read it backwards. So I've got 2 sine squared x minus 2 sine x, but the numbers will cancel out. So that's what I've got, equal to 0. So I've got a nice little factorisation. So I've got 2 sine x times sine x minus 1 equals 0. From which either this factor is 0, so sine x is 0, nice and neat, or this factor is 0, in which case sine x will be the opposite, which is 1, which again just comes from the graph of it. You would just visualise it, but just for the sake of illustration I'll put it here. Sine graph looks like that. When's it equal to 0? 0, 180, 360, and these are allowed because they're included with the equal to signs. So for this one the answer would be 0, 180, 360, or for this one, only gets to 1 once, and that's at 90. So putting it all together, that means the answer would be in numerical order 0, 90, 180, and 360. There you go.